Okay. So I guess everyone can see my screen and we can move forward with the topic for today's seminar or webinar. Okay. So yes. Okay. So as our webinar states, like our title is for today's webinar is like open source automosaiking with a WebODM and a NodeODM API. So ODM is a open source software which provides a lot of applications. So ODM's abbreviation is like Open Drone Map. And today we are diving into the world of automosaicing using two powerful open source tools, which is WebODM and NodeODM. Orthomosaicing is a critical process for creating accurate geospatial maps, and these tools make it accessible and efficient for everyone. So, by the end of this presentation, you'll try to understand how to use these tools, their benefits, how they fit into modern workflows in industries like agriculture, construction, and etc. etc. So, drones are nowadays a big game changer. So, you need to know how to actually use the inputs, that is like the outputs from the drone, and use it as an input and make it as a application based kind of output. Okay, so introduction to orthomosaicing. So orthomosaicing combines aerial imagery into a distortion free georeferenced map. Think of it as turning a series of drone images here, like this is a series of drone images into a single accurate map that can be measured and analyzed. Tracking combines all aerial imagery into a georeferenced map, which is distortion free. Okay, we will think of it as turning a series of drone images of turning a series of drone images into a single and accurate map that can be measured, analyzed, and maybe more outputs can be derived from the georeferenced orthomosaic image. Okay. So, what makes orthomosaic so valuable in this precision? So, they are adjusted for elevation, terrain, and any distortion in the lens. So, this technology is vital for application like precision farming, urban planning, and environmental monitoring. Okay. So why you guys like that is like the end users are now supported with the orthomosaicing process for the drone imagery is with their all single products they need to like stitch all these images into one into their respective AOI, and they need to actually use these outputs for their own customized purpose. Okay, most of you like would have heard other base maps like Google Maps and over some OpenStreetMaps which has these kind of data. But at what level is the biggest question why we actually use our own orthomosaicing process. So accuracy level is the biggest difference, and that is like the spatial resolution of each base map or the orthomosaicing image which we actually get from the drone. We nearly get like 1 meter accuracy from our own drone orthomosaicing data, but for the open source data which is available as Google Maps and Bing Maps, all the satellite imagery have minimum it would be starting from 20-meter resolution. So that is like if you need a lot of informations to be added from the from our own data, you need to actually you start understanding how orthomosaicing works, and you need to spend your money to actually get the drone data from for your own AOI to get a lot of accuracy details. So RGB orthomosaicing can be done irrespective of the input. Only thing is like you need to remember that there are a lot of parameters which we need to actually keep in mind before doing orthomosaicing. Okay, so yes, I guess we have a question from Mahin. Yes, Mahin.
No, I don't have any question. I clicked it by miss. Sorry.
Okay, so okay, no issues. Yeah. Okay, so there are essential elements which are actually like dependent for automosaiking data. Okay, for accurate automosaics, we need quality data inputs. So high resolution geotagged images are fundamental. So they provide spatial context. So calibration data ensures our images align accurately while the coordinate reference system standardize the output format. So for the geotagged images, high resolution imagery with metadata, the latitude, longitude, altitude, and sufficient overlap should be there. So overlaps, it's like two images side to side. You need to have a minimum of 60 to 80% for stitching, so that if there is a lot of sufficient overlap, your orthomosaic images will be better. If there is like minimal, more less than maybe like 40% or 30%, then your auto mosaic, if there is any distortions in your subsequent image, that is if there is okay, I'll just explain you in two tiles. Okay, so this is your image one, and this is your image two side by side, which is overlapping at the percent of 80%. Then, if there is any distortion in one of the images, it will take the image which is actually having higher quality of data and higher spatial, that is like no distortion kind of free data. If there is like more than 60%, it is like more useful because like it can correct its own data by using the data which is like more what is that distortion free, and which has like more pixel value data. So if your data has like 10% of only 10%, so only this much data is your overlap, then like if there is like any distorted data here, and it is like distorted data even in the background, then most of your data, nearly maybe like what you can say you can actually see that there will be like nearly 70% or 60% more data which has been distorted. Okay, so it's good to go with higher overlapping percentage, so that parameters you can actually induce in your own drone software to whenever you're trying to actually automate the process. If you're not automating the process, um, you can actually like manually go and change your overlapping configuration in your drone deploy software or other open source software which is actually used to start off the drone survey. So remember 60, I will recommend 60% minimum to actually go forward for a auto-mosaicing stitching process. Yes, again, there will be higher data if you have like 60% overlaps, but again, end of the day, you need a better accurate results, right, as an output. So it's better to go for 60% rather than lesser percentage where you will actually like get distorted images if your drone is actually shaking due to any kind of physical things like wind or other things like battery or cameras gimbal movement. Okay, so the other element for elements for automosaicing data is camera calibration data. So your focal length, sensor size, and distortion parameters should be actually like given as the default. That is if there is a default value for each drone providers you can give. Else you need to actually find out like which kind of parameters like you need to choose for your own specific drone, customized drone. Okay, so your coordinate reference system, which is if you're a GIS person, you know how CRS works. Okay, so if you know the CRS of your drone data, you can actually assign it. Else, you can go for the WGS84 system, which is like 4326 EPSG code, or the 3857 EPSG code. If you're trying to actually measure the data and do like measure kind of analysis, I would suggest you need to actually go for the UTM zone which you are actually trying to survey. Okay. So the fourth point we will actually like look on, which is ground control points. This is an optional but a recommended parameter. why why actually I have mentioned this as optional is most of the drones which are now designed will actually geotag the photo whenever it's taking a photo. For instance, I'll just show you in my QGIS application a photo which was taken from my DJI drone. So this would actually have all the metadata information, so you can actually go and check the properties, and the metadata informations are available in the information tab of QGIS application. So whoever has the knowledge of QGIS, you know what I'm talking about, what metadata is. So metadata is a data about data. So our data is now a drone photo, and that data will contain extra information about each exposure band, file source, and there would be like GPS latitude and longitude. So your latitude and longitude values are also here. So it's already geotagged, and all your information is already readily available as a metadata in each of the data sets. So you don't have to actually that is why I have mentioned that ground control points are optional but recommended. So why it's actually given as recommended is it is an extra information if you're trying to get the ground control points. For instance, like you have a DJI drone which actually automatically gets the photo geotag, but for higher accuracy, you have actually attached new GPS instrument into it, which takes regular regular information of the exact position of the drone. So if that is actually installed in your DJI drone, maybe like you can use that ground control points from the GPS instrument with the time zone, and you can actually use those accuracy. Maybe DJI drone geotags the photo with 3 decimal places or 4 decimal places of accuracy. But GCP instrument can give like 10 points or more than 10 points, decimal points accurate data from its own GPS reading. So the accuracy will be better if your DJI drone fails to actually connect to any one of the satellite to get the GPS reading. Then also you can use the GPS reading from the external GPS instrument, and you can actually geotag the photo and replace the coordinate system. Okay, so flight path information and digital elevation model is optional. So it's not a mandatory one to actually use this elements for orthomosaicing data, but it's an added on information to be used. Okay, so the key objective for this essential elements is we need to ensure all the data completeness is available and the quality for accurate orthomosaicing generation. If any one of the mandatory is not available, then obviously you can't do the orthomosaicing process. So optional parameters, like yes, you can actually miss out the optional parameters till you can get an orthomosaic photo. But again, optional parameters will actually enhance your output, and it will actually give you more details for your spatial analysis. Okay, so moving forward, we will actually have an overview of how what is WebODM and NodeODM, and we will actually I have actually attached the screenshots of how the application looks. So WebODM and NodeODM are two sides of the same coin. WebODM offers a complete user-friendly solution, ideal for end users looking to generate maps with minimum technical efforts. So whoever doesn't know development, they can actually opt for WebODM. So WebODM doesn't require much of the development expertise. So whoever is actually moving forward to be as a GIS analyst, they can start using WebODM. So NodeODM on the other hand, is a developer's dream. So it's a lightweight API focused tool for automating workflows and handling large scale data processing. don't worry, like I'll just let you know like what API is in another slide. So for now, you can understand that it is actually like a lightweight API focused for automating workflows. So you can use this API to integrate in your Python script, and straight away, like in a one click, you can actually get the output out of the NodeODM. So together, these tools provide the flexibility to suit both technical and non-technical users. Okay. Okay. So these are the two screenshots which are available of the application. So the first screenshot is the WebODM application where you can see the dashboard kind of feel. NodeODM API, it is like a simplified what is that application kind of thing where you won't be using much kind of application based uploads and all. But you would be using this API to actually like be used in your automated script for Orthomosaics photo. Okay, so I guess like we have someone who has joined. I'll just on it. Okay. Yes. So moving forward, I just told you like what WebODM is. So WebODM, like whoever is not a developer and who is actually like needs these kind of application to just process their images and get the output. So all the manual works you need to do without doing the automated workflows using Python or any other automation script. So they can choose WebODM and NodeODM API are purely for developers, and it is like actually as I said, it's actually a developer's dream to use all these kind of APIs to automate their workflows to get the process in a single click, so that like all those manual processes is actually like eliminated. Okay. So the main feature that is like difference between a WebODM and NodeODM. So interfaces like WebODM GUI is actually easy for management, but NodeODM is actually like a CLI based, which is like a client based one, which is like no graphical, no not much graphical interface. You won't be using graphical interface just like you will be using the API. If you need to use NodeODM API graphical interface, you can still use it, but it doesn't make much of a difference using WebODM and the NodeODM. And the use cases are for WebODM. It gives like full solution for the project management, and NodeODM, it is a lightweight processor for customized workflows. You can customize the NodeODM more frequently with the open source code available from the API. But WebODM, like whatever like is present in the application and the workflow, you can't actually like modify it. Installation, similar installation, you need like Docker and a Windows machine or a Linux machine to actually install these kind of ODMs where you actually like pull out these applications. So yeah, moving forward, I will tell you like detailed explanation of the installation part. So I'll just jump on to the scalability. So it supports multiple nodes for distributed nodes. Nodes, it's like it is like WebODM. The ODM, that is the Open Drone Map, actually has nodes to actually provide the users certain nodes in their CPU. That is like the processing machine they have to process their orthomosaicing data. But here in NodeODM, it is not dependent upon any nodes. So it is a cluster of nodes where like you can derive the node and you can use the process, and you can actually like increase the whatever the development side of processing, so that like your processing speed will become like efficient, and becomes like less time consuming. So customization. So as I said, like Node ODM, like it's highly flexible for integration, but WebODM, you have like limited GUI based options which you can't actually like use much of customization. Yes. Yes. Someone wants to talk? Uh, Again, Maheen, like, is it like your question or is it like by mistake? Okay. So I guess like, yeah. So I guess like, I got a distortion from you guys. So I'll just move forward with the next slide and I'll be just showing the demo of how it is done. So we actually like found out. I just gave you the difference between how WebODM and NodeODM works. And WebODM is for users seeking for a complete solution, while NodeODM is a lightweight, flexible option for developers. Okay. So what is API? We need to understand what is API. So API is an application programming interface. It's a set of rules and protocols that allows different software applications to communicate with each other. It acts as a bridge between systems, enabling them to exchange data and perform function without sharing their internal details. So it is actually API are like bridges between application, allowing them to communicate seamlessly. For example, APIs enable apps to integrate services like Google Maps or payment gateways without reinventing the wheel. So the source code is not actually like being disturbed. It is just like it gets the services only from the respective sources. Okay, so they are incredibly useful for developers, saving time, promoting modular designs, and ensuring scalability. You can actually minimize a lot of time using the APIs which is available. Okay, so the benefits is facilitates interoperability between system interoperability. So the operation between the end user and the API will actually like be less what is that less time consuming. You can use the API straight away and get the source code to use its function, and you can from the developer's perspective, you can actually modify the code, customize those workflows, and you still like you are not disturbing the core elements of the workflow. You are just customizing your workflow with the core workflow only in your developer perspective. Okay. So in simple terms, API enables apps to talk to each other. So you can actually like easily communicate with the application based interface, and that interface will give you the results straight away whatever you are looking forward. Okay, so that is how like no API works. So why we actually got an intro of API is NodeODM is actually an API which we use for like automating a process of Orthomosaic. Okay. Yes, setting up WebODM and NodeODM. So there are two things like which is a prerequisite. So Linux, Windows, any OS you can actually install, or Mac OS operating system, and you need a Docker which is to be installed. So in the coming slide, I will explain you in detail like what Docker is. So remember in mind, any OS, any of the three OS you can use, and Docker should be installed respective to your own OS. So the steps for the second step for WebODM is install Docker, pull WebODM Docker image, and run the WebODM. Okay, so WebODM installation is a straightforward installation where you pull the image that is like WebODM image from the Docker. I'll explain you what WebODM image is and Docker itself in the next slide. And you can start the application. But NodeODM follows a similar approach, but it is focused on API usage for processing workflows. And it's not like you use the GUI kind based of thing. So this modularity makes them highly adaptable to different project requirements. So this is the basic setup. I'll just go through what Docker is. because most of you who are actually working, who are actually like working in as a GIS analyst, don't have the knowledge of like what Docker is, but it is essential for you to actually know what Docker is to set up WebODM. So developers, like I guess, like some might have heard, some might not have heard. So for those who have not heard, I'll just let you know what Docker is. So Docker actually simplifies application development by bundling everything which is needed into one, maybe like code, libraries, and even the settings. So it is actually bundled into containers. So this containers we can actually like easily pull these containers. So we can straight away use these containers, which is already deployed and being used in one of the application. So you don't need to use install all the dependency files and all the installation files and all the parameters which you need to customize. You can just pull the bundle, which is actually a portable container, and you can straightforward use it. Okay, maybe like you can think of Docker as a lightweight alternative to virtual machines. So it is not a physical mission, but a mission inside a mission. Okay, so for instance, you are having a Windows machine and you want to install Ubuntu software inside the Windows machine. That Ubuntu machine is actually known as a virtual machine. It is not a physical mission, but it is a mission inside a mission that offers consistency across development and production environment. So Docker is central to running WebODM and NodeODM, ensuring stability and scalability. So why Docker? Okay. Uh, if you just visit our website for Open Roadmap, so you just visit the WebODM installer, you can see that there are two things in installer for WebODM: manual install and WebODM installer. If you choose as an installer, then like your ODM process, wherever whatever you're doing, is no longer open source. Now it becomes, if you choose as an installer where you it has an exe file, you will have like all the GUI application, but it is all under paid version, and you can't actually like use ODM as an open source. So as I suggested, this is an open source software. I don't want to purchase a standalone installer. Okay, so I will be going through how to actually go through this Docker installation process, where like Docker installation is like you can actually like search in for Docker installation Windows, and you have this straight away like install Docker Windows, and you need to actually choose whether you have like 64-bit machine or 32-bit machine for Windows, and even like Linux and other things are actually also installed. After installing it, you need to actually have a virtual OS. Okay, for that you can use Microsoft Store to actually install anything. For instance, like since I have already a Windows machine, I actually like prefer to use Ubuntu software, where like I can actually like get a feel of using Ubuntu machine. So Ubuntu, like mostly like it is a command based kind of OS, where you can actually use like commands to get the process done. And there are a lot of advantages using Ubuntu machine, where like comparing to Windows machine, Ubuntu machine, since it has like less GUI and other things, which is like less graphics, all the command line based instruction will be like much faster when compared to Windows. So if you search Ubuntu, you can actually get like lot of Ubuntu versions, which is like LTS and other things. Try to actually download Ubuntu version, which is an LTS. So it is LTS means it's a long-term service. So it is actually stable. All the LTS version will be stable. You can actually download any one of the LTS version. For now, like I have installed Ubuntu to 24 version, which is like an LTS version, and it is running in the background. So you need to have an OS. So after integrating your Docker, it will identify your virtual OS which you have installed, and it will try to actually what is that? It will actually try to actually run the OS from the Docker. Okay, this is how your Docker setup will be, and in your settings, automatically you will get the extension which is like Docker engine, not Docker engine resources. You will actually going. You need to see whether this enable resource saver is actually enabled, and or the WSL integration, which is like the virtual software we needs to be like it will automatically like include when you are installing Ubuntu before installing Docker. So it is good to install the Ubuntu virtual OS first, and then your Docker installation will be like automatically detecting every that is like the virtual OS which you have installed. Okay. So yes, so Docker becomes your critical part for installation of WebODM, since like you don't want to use like proprietary, that is like paid version. So Docker installation, if you want to do, you need to actually install Docker and this virtual OS to move forward to use this WebODM software as an open source software. Okay. Yes. So, quick start with Docker for WebODM. So, getting started with Docker for WebODM, it is quick and efficient. The process involves cloning of the WebODM repository, running the setup script. For NodeODM, you can use a single Docker command to launch the service, making it accessible at a specified local port host. Okay. So as I said, a web ODM container is a lightweight, standalone, and executable unit of software that includes everything needed to run an application: code, runtime, system tools, library, and settings. Everything is predefined. You don't have to actually like get the dependency files, set up the system tools, set up the runtime. Everything like it has been like given in your plate of food, and you just need to actually use it and consume it. That is the straightforward advantage of using containers. Okay. So, quick start with Docker, how to actually start the WebODM. So, after installation of Docker in your system, so from the Docker installation, you need to actually use this what is that URL, which is the git clone GitHub. So this code will be available in the software GitHub itself. So here the manual install. If you go to GitHub installer, you will have this code available, which is like described here in the GitHub account. Okay, so installation with Docker. So once the GitHub is sorry, the Docker is installed, you need to clone the all the Git repository codes. So whoever is a non-developer, try to understand this is actually like trying to extract the code from a repository which contains all the resource codes, all the functionalities. Okay, after which we will change into the WebODM folder and we will start the application. Okay, so this is how you start off the WebODM. NodeODM, as I said, like it is a simple process. You no need to clone your what is that Git repo into your Docker. You just need to actually like do this, which is the Docker installer, sorry, Docker run with to be run on the 3000 port. So there are two things like your WebODM will be running on 8000, 8000, and your NodeODM will be actually like running in three triple zero. Okay, so I just made a mistake in my slide. I guess like this one is NodeODM. Okay. Yes, and you can access both of the application as a local host. So try to identify your local host using IP config, and you will get your local host IP config. So replace that with local host, and this will be your port for WebODM, and 3000 will be your port for NodeODM. Okay. Okay. So the workflow for WebODM. So as I said, manual install, GitHub install, as I said, as I given. And WebODM install, it's a paid installer which doesn't actually suffice our purpose, which is using the ODM for an open source purpose. Okay, so we actually went with the GitHub install of using the clone repo of the code into the Docker. Okay, so WebODM follows a clear user-friendly workflow. First, it authenticates yourself to access the tool. Then it creates a project and upload your software. Okay, so authentication is the first processing in the Orthomosaic process. After authentication, that is like after creating your login and other details, you will get into the dashboard. So I have already started running the process of WebODM, which is like I've started the process in my GitHub, Docker. So it's already running with the code which I've given in the previous slide, and it has been running in my local host, which is the localhost IP address dot 8 000 port. Okay, so this will be your dashboard, and this is the WebODM of how you can do. So since I have already had the login, I created the login. It's a free sign up. You can sign up for free, and you can log in straight away using the login credentials which you have created. After which you can have these. This will be your dashboard, and you can actually create a new project if you are actually working on a new project. And okay, 2 minutes. So I guess we have. Okay. So yes, moving forward, this will be how our WebODM application looks in our local host, which is derived from the Docker. So your Docker should be running in the behind, so that every application and every functionality will be dependent upon its services. Okay. So once that is done, you can actually add a project to segregate your project, or else you can actually straight away use the select images and GCP. So here if I just select, I have sample images in which is collected from a drone. I showed you that these kind of drone photos, it is already available with the geotagged photos. So do I don't have the GCP points in a separate CSV format. So if you have a GCP format, a GCP file, you can actually add the files and the GCP file in this in one go. Okay. So since this is all geotagged, I will actually use minimum 5 images should be used to actually Orthomosaic. I'm using the first five to see how it is actually getting processed. Okay, it will show you how these data are actually collected, and it will give you an overview of it. So the name of the task, it is auto generated. If you want to edit it, you need to use the paid version. So the processing node, it has been assigned by the what is that WebODM, which is actually giving the service. So options you have whether it is a high resolution photo you want, or the fast auto photo. Fast auto photo, you would get something as a quick output, but you would actually have issues with resolution of the image. Okay, for now, I'll just use for fast auto photo for giving a demo, and there are other options. So if you are actually getting like a 3D model or a building or a DSM DTM kind of input, you can actually choose that specific data, and you can actually process the data. Okay, so if you want to resize the image, or you can resize image to certain pixels. So I will just keep this as a default. So resize, resampling, you would have heard if you are a GIS person. So every photo needs to be resized into one specific format, so that all of it is in one specific pixel size. Okay, so after which I'll just click on review, and I'll just start processing. And I think since I just click fast auto photo with five data sets, it has been completed in nearly 5 seconds of 2 seconds to upload. and you can see like it was resizing the images, and after resizing is completed, you can see the processing which is being done using the NodeODM. Okay, so this will require time, so you can't actually complain much because this is a freeware software, so you need to actually sacrifice these kind of time which is being consumed, because if you are willing to pay and want to minimize this process, you can straight away do it. But as an open source software, you can't actually complain much with the time of processing. It depends upon their availability of processors which are free for doing this process. Okay. So yes, it will take up to max, like for 5 images to take max about 2 minutes or 3 minutes. So I think it won't take much. But if you're doing other things, which is like bulk upload, you can still use NodeODM, but again the processing speed would be the same. But at up to a certain threshold, you can maximize the speed of processing. Uh, but again, there would be some issues of the speed where you can actually you can't minimize up to certain level. So using this open source, there are limitations to use these, but still you will get an answer at free of cost, sacrificing the time. Okay, end of the day. Yes. So I guess nearly 70% of the processing is completed, and I think you will be getting an output in another 2 to 3 minutes. So in this waiting period, if you have any issues or anything you need to discuss, I'll just take up the questions from you. It's been completed, but still I can wait a minute to actually get some questions from you. Uh, Maybe if I'm going too fast, or if I need to actually maybe you can ask me any suggestions or things. Okay. So I guess nothing from your end. I'll just resume my process of showing how WebODM works. So there are three things. That is uh, after the completion, as I said, the 5 images, it just took less than 2 minutes to actually upload and process it. Okay. So once that is done, you'll have these kind of options, which is you can restart the output, or you can download the assets as a author photo or camera shots. I will just click on author photo because we are specific to this exercise, webinar for author photo. Okay, you have the projection system, which is UTM zone, which is already defined. My zone for the data is 32644, which is the UTM zone. And if you want the GeoTIFF RGB image, JPEG image, so the default one for GeoTIFF, I will actually use it to download, and you can see this orthophoto image where it's not continuous, because I have chosen the first 5 photos, but still if I choose all the photos, that is all the photos which I have, maybe we can actually fill this gap. So I think two images here and three images here have been orthophoto. That means stitched, and for actually doing that is if I upload all these 20 photos, I'll be getting an output which is similar to this. Okay, so this will be my output of the author photo, which is of all the 20 photos. So since I need to actually limit the processing time, I actually used 5 photos, which is actually not in the same what is that same photos. Okay, so you can actually import this photo into your maybe QGIS application to view it. So this is the output of auto photo, which is got from all the 20 photos, and you can actually use any one of the quick map services, base maps, to actually see how your photo has come up. Okay, so this is your auto photo, and we have a base map here. Okay, So there are changes like in Google satellite would have been like taken at different timing, and this would be actually like taken at different timing. So there will be changes in what is that what is that plans and other things. But you can see that there are trees which is like identical, which is not disturbed for the last 10 years maybe. Okay, so it is like more accurate. The shift is, and it has like more spatial resolution. You can see the even like each branches of the tree in your ortho photo, and you can see even a I think like maybe a building, and I think this one is a well, and this is maybe like a photo that is like something which has been kept. So those kind of you can see the well here, but the orthophoto image which you got from the well is like more spatial, more having more spatial resolution. Okay, I think this is the man who was there during the drone survey. Uh, so you actually got these kind of data. So yes, there is some distortions which are available in this photo, where like I think like the minimal distortion which we have is like 30% we used. So that is why we actually got distortions here. So since there was a shake in the camera, the orthophoto hasn't stitched here well. But here, similarly, the same orthophoto has like 30% distortion, but the camera at this position hasn't shaked much. Okay, so that is why like I wanted to show how these kind of overlapping photos you need to actually take care of to get like more accurate data. So here and all like the distortions is not like much, but on the exterior side you can see like a lot of distortions which has been done, and I think like yeah, here and all like less distortion, so there is not like much of a camera shake. Okay, so yes. Okay. So moving forward, this is the output which I got for as an author photo from the WebODM application. If you want to view and map straight away and not use the QGIS application, you can still see that two splits which we have worked on with the five sample images. And maybe like there are certain tools, the GIS tools, which you can actually see. So if you have like a point cloud data, you can use like a 3D view data on it. And since this is like a DJI drone, like it actually kind of collects the point cloud data of the information available. Okay, so you can see all the trees points here, highest points, and yeah. So elevated points are actually marked at a higher perspective. So there are other the analytic tools which are available, which is like measurement, height, and maybe like you can move and other things, which is like all the GIS analysis guys. Like you can actually self-explore to use in your own what is that data. Okay. So yes. So there are tools which are available. Online there is like WebODM application itself. If you want to use in your own application, you can straight away forward the asset, sorry, download the asset, and you can use it in your own asset. Okay. So yes. So once this is done, I think like you will your first project tasks will be here, and you can still like download the assets in what the formats which we are which the WebODM actually gives out. So this is the generic view of how WebODM is being used. As I said, like this is an open source software. It is like if you have all the data which is available, you can straight away use this. WebODM using the installation process which I have given here. So yes, moving forward, as a developer perspective, whoever like wants to automate these kind of process instead of uploading these images, I want to automate the process. So we will jump into NodeODM, which is like using the NodeODM API, how to actually like use this. So the workflow of NodeODM, like there are no installer processes for NodeODM. It offers more programmatic approach. So developers start the NodeODM server and interact with it through API requests. So we need to send like a request through API through their API, and they will actually send the output as a diff file. Okay. So images are uploaded, processing parameters are set, and the tasks are submitted for processing. Okay. So the processing of NodeODM is start the NodeODM, upload the images, set processing parameters if needed, submit the task, monitor the task progress, then download the results. Okay, so yes, so I'll just show you how NodeODM application will be in a GUI. Okay, so as I said, like it is available on what is that? The local host, HTTP local host, and which is available on 3000 port. Okay, so yes, you can actually like you use the GUI also, but it doesn't make much of a difference between WebODM and NodeODM. Okay, so if you want GUI kind of upload and processing things, you can straight away use WebODM. But here, like you can still use the GUI kind of process in a NodeODM. But what I would suggest is you need to actually automate this process. You need to understand these processes. Okay, so if you're actually like starting a task, this is like start task is here, where you can actually like, first you need to upload the folders, just like WebODM if you're using a GUI, and start task. After you have started the task, you will actually get an UUID, which is like ID, unique ID for actually the process which you are uploading, and the name of the task, the images, how much you upload, the status of it, and the time elapsed and other things. So I have actually like automated the workflow where I have got all the workflows to be given. So I have given this is a Python script where I have used the localhost application for NodeODM URL, and I have given my project name as an input parameter. My input photo directory, which contains all the JPEG images, and the output for that is the output path which I will be giving to actually download the dataset once it has been confirmed. Okay. So the first line of code, it actually like initializes, gives a checks the URL and tries to get the UUID, unique ID from the NodeODM. Okay. So once that is done, the next step I have automated the process of uploading the photos, where I will give only the directory where it contains all the JPEG images. Okay, so this line of code will search for all the .jpg format, and it will try to upload every JPG format. Okay, so all the JPG formats will be uploaded in the directory, and this process will automate the process of upload. Once that is done, the this methodology is to commit the task. For each upload, you need to commit it. So once the UUID is got, we will be committing each task to save the task. And once that is done, your process won't be like given in an output. You need to actually check the status. I have actually like given a methodology here to give check the status at a regular interval of 30 seconds. To actually, if you can see, I have run the script here, so you can see at regular intervals. So uploaded the images, the process been is being displayed here. So upload which kind, which JPG images are uploaded, and you can see that the commit has been done, and the unique ID is got. So UUID is got, and after which the processing starts at regular intervals, 10 seconds intervals. I have given to check the process and get the progress, so that like we need to know what kind of progress has been done without the GUI. Okay, so that part like we actually got it in 10-second refresh rate, and once that is done, I think like it has taken nearly like less than 10 minutes. So for 10 seconds interval, like we have got like these kind of outputs. Once the progress has been completed, you will be getting auto mosaic process completed. If there is any issues, I have actually given a else clause where like there is any issues in Orthomosaic, maybe internet issues may be there, maybe the data you are uploading is actually like a high risk data, that is like maybe like you're using something which is like a list data, or like a sentinel data which is like having lot of pixel value. You can't use those kind of imagery. You can use only like a drone image photos which is like less than 1 MB or less than 10 MB of size, each image, each single image. Okay, I'm talking about. If you're using an image downloaded from Landsat, which is like nearly 700 MB, you can't actually like process those kind of data sets in NodeODM. Okay. Yes, there are some things where I think like Landsat 4 and 5 can be used, which has like 50-meter resolution. So I think like you can still use that, but using resolution data for a higher area, maybe like 250 square kilometers, which is like for Landsat, you can't actually still use it. Okay. So yes, as a drone pilot and as a drone data processing group, you need to actually use your drone data to upload these kind of data, and you can automate that workflow. And once you get the UUID, you can push it with the UUID with the uploaded photos, commit the task, and end of the thing, like you can actually like get the output sample without even actually going in through the GUI application. So I just this process is all. I just clicked on this process, and all these processes has been completed using the code, and it has been saved in the location, which is like this location. I can actually extract the output. Okay, so it's already been extracted. Okay, I guess like okay. So this is our output zip, which contain all the photos. So yeah. So this is a bigger image where like all the distortions has been corrected with all the images. Okay, so I can actually like you can use the I can show you how the sample data is differing from, because like I use like all the data in the NodeODM. You can see the distortions has been minimalized. Okay, so a clearer orthophoto with a lot of images can give you an orthomosaic similar to this image, where the distortion at edge you can actually like get the distortion because there are no supporting images, but in the center you can see the difference between this image and this image. Okay, yes, so yeah, so we'll move on to the slide where we'll actually like talk on how it is being like used in many kind of application. So advantages of using ODM thing, that is like open drone map is like open source. ODM tools stand out because they are open source. Okay, which means they are free and highly customizable. They are compatible across every operating system, making them versatile for users with different setups, maybe like Linux, Mac OS, or a Windows, or any OS. With support for distributing processing, and a thriving open source community, ODM ensures you can tackle projects of any size with any confidence. Okay, so you don't have to rely on the proprietary softwares which are available for orthomosaicing your photo. You can straight away use these kind of processes where like you can rely on your own customized product and give a high quality results depending upon not depending upon other proprietary software. Okay. So the rich outputs you have got like the auto photos, them 3D models, point cloud data with high accuracy. And the other thing is like open algorithms allow users to understand and trust the processing workflow. So the key advantages of using an ODM is ODM offers cost effectiveness, flexibility, and a powerful output compared to the proprietary software solution. Okay. Yes. And coming back to our last slide, there are other products of ODMs which are still not explored and which is not part of our webinar. So you guys can actually take time to actually get these hands-on thing which is available on the Open Drone Map software. Cloud ODM, it is a cloud API for processing drone imagery remotely, enabling scaling and convenience. So PyODM, Python client library, whoever is a developer can use this PyODM interacting with NodeODM and automating process. So whatever we did in a Python code is like PyODM, and cluster ODM is like a load balancer that manages multiple NodeODM instances for distributing processing of larger data sets. For instance, if you're doing this automosaic in large scale, you can actually use their application called cluster ODM and try to actually use the load balancer to manage the multiple node ODM which you are using. Field ODM, it is also an application of ODM which is a lightweight interface designed for field use, ideal for quick data uploads and basic processing. Okay, so if you are a guy who actually like goes to the survey and wants to do the automosaicing process on the flow on the survey area itself, you can use field ODM. Lightning, it's a hosted cloud platform offering on-demand processing with ODM technology. It is like a quick process, but like you have to compromise on the output of the data set. Portable OpenStreetMap, a field-ready toolkit for an offline data collection software, and ODM. So it is integrated with OpenStreetMaps. So you can use even though you can try on the even portable OpenStreetMap to integrate all your data into your OpenStreetMap. Okay, so the key strength, the ODM ecosystem provides tools for diverse use cases from local processing to scalable cloud solution and API integration. As a GIS analyst or as a GIS person, I would always recommend for you to actually work on an open source environment so that you don't indulge in your proprietary software which has all the setup which has already been done and you have to pay for it and your client also needs to pay for it and it becomes like a huge headache for you guys. Okay. Yes. To wrap up, WebODM and NodeODM provide powerful open source solution for automosaicing. Their cost effectiveness and flexibility make them ideal for diverse industries. So by leveraging their unique features, user friendliness like WebODM and automation in NodeODM, you can create workflows that are both efficient and tailored to your needs. So yes, thank you for your attention, and I would be happy to take any questions from you guys. So, yes, anyone who wants to actually like ask me any questions, like I'm open to your questions, and I think like we can. Yes, yes, I am not able to spell your name. It's Pavel. Yes, Pavel.
Yes, it is Pavel here. Well, Node ODM looks a bit complicated as for myself, but Web ODM, is there any limit set for number of photos which it can take? How is it?
I didn't get you, Pavel. Can you just come in? So you are trying to say that the process is a bit complicated. I think
No,
your
no.
best, yeah.
When I look what you showed in terms of Node ODM,
Yes,
it is quite complicated as for me.
yes,
Okay.
exactly,
Uh,
exactly.
yes, but WebODM looks a little bit simpler, no, much simpler.
Yes,
And now my question is whether there is any limit in terms of number of photos WebODM can process. Can I
yes.
process something like 1,000, 1,500, 2,000 photos in
Okay,
WebODM?
okay. It doesn't depend. It doesn't depend upon the number of files, but it has a limitation of the size. Okay, so the size of photos which you need to upload shouldn't be more than 5 GB, I guess. So
Bigger than what? Sorry, say again?
it doesn't depend upon the size of, sorry, the number of photos which you upload, but there is a
Yes.
limit size which you need to upload for WebODM. It shouldn't
Okay.
be more than 10 GB of data or max data. So maximum, like you can process a 10 GB data of all the
Okay.
photos. It is not the number
10,
of photos.
10 gigabytes is
Yes,
the
gigabytes.
limit for 10 gigabytes.
Yes, exactly.
Okay, per project.
Yes.
Okay, understand. Okay, and the other thing, I can see that WebODM is capable of processing multispectral.
Yes, your multispectral is still like can be used, but again, I have tested on Landsat 4 and 5, which has like lower resolution. But again, like you need to resize the Landsat to minimum, sorry, maximum of 4000 by 4000 pixel size, so that like your data will get like reduced. And yes, you can use for 4K cross 4K size of data from a Landsat. You need to resize it, and then you
No,
can
no, no,
use.
I'm talking about drone multispectral,
Yes, you can still
not the
use.
satellite.
Yeah, your
Okay?
drone multispectral will be like 2048 pixels only. So I think like you won't be having any issues which is like less than 4000 cross 4000. You can still use it as 2048 as 2048. As I said, WebODM has an option of actually using uh, the data that is like data to be actually used as a multispectral or a single spectral. If you can see, like if I can I'll just select the 5 images again. I showed you a drop down of what are the options available here. So here you
Yes.
have multispectral options here.
Okay, and then I have to tick on resize
Yes,
images.
yeah, exactly,
Okay,
exactly. And then
okay.
you will get a multispectral output.
Okay, what about imagery of reflectance panels?
I didn't get you. So reflector panels, you need to actually pre-process those kind of imagery with your
Okay,
reflectance
so,
values.
uh-huh,
That
but,
is the pre-processing and not the orthomosaic part.
okay, okay. So how does it work? What's the workflow?
Actually, all the reflectance value which you get using the field data, that is actually pre-processed using the software, not apart from WebODM. That is not a part of WebODM. That is a drone processing software which you need to use. This is the
Uh-huh,
orthomosaicing software. So these are
uh-huh.
totally different. You can't actually
Okay,
combine these two.
okay, thank you.
Yeah. Thanks. Yes. So I guess like it was good meeting you guys. We had a good session, and you can still like if you want to actually learn these things in detail, we still have this course like as an online course. You can join the course, and we will be giving you the stepwise process. As like Pavel said, he was having difficulties to understand the node ODM part. You can actually jump into our exercise course materials, and we can actually provide you a customized option how to do this process in a NodeODM, where you can single click the Python script and you can get the output as a single click output. Okay. So yes, we have this courses available in our websites. You can actually go through it. You can actually ask our sales team regarding your customized option, and we will be giving you detailed course material. And yes, moving forward, you can actually use these kind of tool sets, and it will be like a game changer for your drone application. Yes, thank you guys. Moving forward, I'll just type in our website, which is uh, AGSRT. So we can actually type in AGSRT, and you can actually this is the website, and there are a lot of course materials which are available. You can just go through. So apart from drone, if you guys need any support in GIS in any other applications, we have like lot of spectrums of courses available, and you can actually like go through that course. Okay, thank you guys. Have a great day.